Hi, MRK here, and today I'm gonna show you how to make metaballs. It's a topic I was interested in many times and I have not found a solution until now. You probably wondered, or maybe not, but you might in the future, how to make a slimy ball or glue or whatever that just snaps to surfaces. And yeah, I made just that. Before I begin, quick intro. If you're not interested in intro, of course, I put a timestamp in the comment. Feel free to click it and it will skip the whole intro so you can just watch metaballs and stuff. And for those of you who want to listen to my intro, I'm gonna do this just once. I mean, a longer intro because it's a pretty special video. Because it's after, well, it's 2 years after my last video, over 2 years, and it's been a while. I was wondering what I want to do with this channel, and I decided to just focus on game dev. So from now on, I'm gonna make just game dev videos and my adventures with Unreal Engine 5 blueprints, shaders, and all that stuff. Game design probably too. And yeah, all of my other videos have been hidden, all except few. I think 4. I left 4. They are gone, and I'm gonna just focus on making purely game dev content and stuff that I find interesting and stuff that people might want to know, and the stuff that is not very common. It's not a common knowledge, but I might do some of those later, just for fun. But yeah, stuff that it's not on forums, not really on YouTube, and yeah, I think YouTube needs more cool videos about game dev. Okay, so let's begin. The most common way to make metaballs, or the way people convey it on YouTube or on some forums, is actually raid marching, which is pretty complicated to do in Unreal. But there is actually another way that is very simple yet not obvious, and this is the way I found on Prismatica Dev channel. Big shout out to him. Very cool dude and very nice videos. I'm gonna link it below, and so you can watch it and maybe get some more knowledge about this topic. Because basically how it works, it's using depth field. Or actually distance field, not depth field. If you enable, it's in visualize, there is something like distance field, right? And if you enable it, you can see every surface, almost every surface. If you disable this option, of course it won't have it. Every surface has some kind of field around it. That tells you the distance between objects, and metaballs can actually use it to snap to objects, or in other words, modify their vertex data to offset itself towards or in other direction of the surface. Okay, so let's begin with a custom setup. Let's disable this visualize option. Let's go back. Of course, the metaball I'm gonna do is also gonna snap to itself. I mean, not to itself, but to the material of the same type. Okay, so first thing I'm gonna do is create a ball. It can be an actor in blueprints. Of course, I do have an actor, blueprint actor here as my ball, but it can also be just a mesh actor. It doesn't really matter. The only thing that matters is the shader, and that's it basically. So okay, let's make a shape. We're gonna make a sphere. It kind of works in with cubes, but not exactly. There are some problems with cubes. They basically have to have some more surfaces. Like if we take a normal cube, let's make a shape cube, right? You see, it's basically 6 surfaces. So those surfaces are basically, well, planes. Those planes are getting drawn to another surface, and they are leaving a hole in the mesh. So it doesn't work with something like this, but it does with something like this that has some different plane setup, right? So it's not just a planes, but the corners are rounded. So there is more data to manipulate, right? Okay, so let's do this with the ball, and yeah, let's make a new material. We're gonna call it metaball material tutorial, because it is indeed a tutorial. Let's open this up, and yeah, I'm gonna close my previous assets, and let's do some basic setup. Let's just make 0 value, add it to specular, and 1 to roughness. If you don't know how to do this, it's just hold 1 and click, and you're gonna add a constant basically. You can do the same, of course, with 2, 3, 4. If you do 4, then you have a 4D vector basically. So 3 color channels and alpha, which is basically X, Y, Z, and W, right? Okay. Let's also add a color. So actually, I'm gonna make a 4D vector, call it color, and convert to parameter, so we can change it from material instance. So for example, if we want many different colors or textures, then I mean, those are material basics. I'm not gonna really explain it in this tutorial. Let's set it to 1111 and pin it to base color. So yeah, this is our basic setup for a material, and let's add it to the ball. All right, so we have a metal ball material on our ball, and let's start with distance fields. So what node utilizes distance fields? There are at least 2 I know of, but we're gonna do it with just one, and it's called distance from, or distance to nearest surface. This basically takes a position. If you don't pin anything to it, it will just take a default position, so default surface position. And it's gonna use distance field to check all distance fields around it, including itself if it's a mesh, and well, output that value here. And okay, let's pin it to base color. Let's see how it looks. Okay, we have dots, and if we get it close to a surface, we can see that something is happening. This is basically our distance field, right? All right. if we want to increase the distance, we need to divide this value by some other value, like let's do 50, because this node basically does 0, 1, is a value between 0 and 1, and if we want to increase the range, we need to divide it or multiply it. But there is no reason to multiply, because it's gonna just I mean, I can show you in a moment, but basically we can divide for now, and that's gonna increase the range, trust. Okay, so we can see it's all black, and there is a good reason behind it. Because this mesh is taking itself into account. So if we want to actually make it work for now, we can just go to details and turn distance field lighting off. So if we turn it off, we can see it just takes the the other meshes. Sorry if I'm stuck because need water. Okay, water is good. And okay, let's continue. Actually, I'm gonna show you how it looks without divide and with distance off on that mesh. Basically, you can't really see anything. There is a line, there's a very thin line, but nothing that you would really notice. So yeah, if we pin it to a divide, then we're gonna increase the range. Actually, let's make it 150, so it's really visible. And yeah, it takes the value from much bigger range. Yeah, multiply would just decrease the range. Actually, I wonder why it was so apparent when we had distance lighting, distance field lighting on. But well, I guess that's that's a question for another video. Let's just focus on metaballs right now. So anyway, for tutorial purposes and just showing off, we're gonna turn this off, but we're actually gonna turn this on when we are making actual metaballs that can interact with each other. But for explaining purposes, we're gonna leave it off for now. Okay, so we got divide that increases the range, and yeah, we can basically saturate it right now. So it's gonna clamp the value between 0 and 1, and 1 minus x. So this is gonna basically reverse it. Actually, why did I do the saturate right now? It's pointless. So let's just do 1 minus x, but we'll use saturate in a moment. And yeah, the further it is, the blacker it is, basically. And that's gonna be useful in our metaball. And what minus x does it? Basically reverses values. So without minus x, it would just push away from a surface, and with minus x, it's gonna draw itself to the surface. So minus x very important. And yeah, how do we modify the vertex data? Basically world position offset, you could have guessed it already. Okay, let's pin it to world position offset. Let's see what's going on right now. Okay, not much. Not much. Because we are missing one node. And that node is called vertex normal. So we need actual vertex data to modify if we want to use the world position offset. So let's multiply the 1 minus x with vertex normal. Let's see what happens right now. Okay, still nothing. Maybe the value is too little. Let's multiply it by, let's say, 50. Okay, our ball has just increased in size very much. All right. Okay. So we have actually some mesh modification. As you can see, the shadows are a little bit off. I don't know actually how to fix that. I just turn shadows off for metaballs right now. But if you find a solution, let me know. So yeah, actually we have now a metaball that is gluing itself to some surfaces. Very nice, as I might say. But there is a problem. There is a problem with this. Right? We don't really want that. And to fix that problem, we actually have to use the saturate node. Because it's gonna basically remove any values outside the range. And our range that we are interested in is just this, right? Between the minimum value and the maximum value. Anything above it should just stay the same. So yeah, this is a very simple metaball that is working with surfaces. But that metaball will unfortunately not work with each other. Let's duplicate it. And as you can see, this does not interact. And that's because, as you may have already guessed, those meshes do not have distance field lighting. But if we enable it, they are very glitchy. And they do not want to work together. And yeah, there is a simple way to fix that, and I'm gonna show it right now. Basically, we need to how would you say that? You need to take the ball and take it out of the equation. And how do you do that? Actually, quite simple. It's quite simple. You take absolute. It's not called actually absolute in the context menu. It's just world position, but it adds absolute world position. And let's add this to that and pin it to distance to position. I'm sorry. Right. Okay. Now we have balls that are actually working with each other because we have reduced the ball size with its own size basically. And this stuff now works. So let's pin a color. Let's pin a color. Actual color, not the debug color. And let's see how it looks right now. Okay, it's looking pretty nice. We can of course still use it with other surfaces, but we can also use it with itself or with other instances of itself. And that is basically metaballs, and a simple way to do this. The lightning still is still a bit glitchy, but generally it works, and you can tweak it however you want with those values. For example, this is basically the distance. So if we want to keep the distance high, we just keep it high, and this is the effect, how much you want it to be displaced. So if we make the value 20, we guys basically have a very little offset, size offset. As you can see, it's just barely moving. If we increase it to let's say 60, they are basically eating each other out, right? So yeah, for me, the best results I had with the same values, so 60, for example. Actually, it's not. Maybe it was twice the value, so 60, 120. I think it's either that or that, but we checked the same value didn't really work, so I guess this. Yeah, it's not bad. All right, so that's the tutorial. Not very complicated, easy to do, not many nodes, and yeah. If you have any ideas how to tweak it more, and maybe fix those shadows without just disabling them in here, cast shadow, right? Because we can just disable it, and yeah, it's gonna just be unaffected. So if you have any ideas how to fix that, then of course tell me in the comments. And for now, that's it. To the next video, I hope. I think I'm gonna find a few interesting things to show you eventually. It might take a week or two, but let's be patient. Okay, to the next video, and bye bye.